Hello, Stats Kids. I hope everyone's doing well. Our goal today is that you're going to learn the start of something called a one sample z-test for P. Now, just to jog your memory, what you just did, the last unit you just completed, was a one sample z interval for P. That's where we didn't know what the population parameter was. Meaning, I don't know something that describes the whole population, and I want to know what describes the whole population. So I sampled some people, I got a statistic, right? I then built a margin of error and I got a lower bound and an upper bound. And we were confident that the truth, the parameter, the truth about this population was between the lower bound and the upper bound. Well, now what we know is what we're transitioning to, is we know that population parameter. But now we think it might not be right. So we're going to try to prove that it's not right. Now, you can use an interval for this, but you also need to go to college or wherever you're going next, or just to understand statistics. You need to understand something called a one sample z-test for P. And that's finding evidence that that parameter is not correct. There are four parts to it: the state part, the plan, the do, and the conclude. Today, we're only going to go through the state part. So, without any other hesitation, let's get going. When we're practicing just the state part of the z-test, okay, the first thing we want to do is we want to say, well, what is the parameter? What is this story about? So I'll practice it with you, but you always start off with P is equal to the true proportion, blah, 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 whatever you're looking into. So the true proportion of kids going to the U of M, or the true proportion of kids who like cheese pizza, whatever that truth may be. Next, you see something that says HO here. That's actually should be a little sub, so I'm going to change that right now. Okay. H sub 0, we call it. H naught, we can also call it, or the null hypothesis. That's what our current truth is, the current claim that we know. And we always write it as P is equal to whatever that is. And that's always going to be a number. And in this case, it is going to be a decimal. Why? Because we're dealing with proportions, and proportions are decimals. Then the next thing that you need for the state part today is something called the HA. This is the alternative hypotheses. And again, that should be a subscript, so I'm just going to change that real quick. This is what we're trying to prove, okay? What are we trying to prove? So let's just play pretend right now. Let's say, hey, Mr. Norby thinks that 20% of you love cheese pizza, and he knows that I'm a statistician, so he's wondering if he's correct with that. That's the current claim, he thinks. And he wants to know, is it more than that? Okay, so what I would go as a statistician then is I would say P is equal to the true proportion of Armstrong kids who love cheese pizza. The current claim, or the current truth, what's claimed right now, Mr. Norby thinks it's 20%. But he's wondering if he's wrong. He's asking me to find evidence if maybe it's more than 20%. So that's why there's a blank here, because what's going to happen is we're trying to figure out that this truth is wrong. And we maybe think that it's either, or one of three things, okay? It's either going to be less than what the current truth is, greater than that current truth, or not equal to. Again, this HA is what we're trying to find evidence for. So today, the three things that you need in your worksheet today are in the notes that we're going to go through in a second. The parameter, the null hypothesis, that HO, and the alternative hypothesis, that HA. So let's practice that now. Our first problem here we have, okay, publishing scientific papers online is fast, and papers can be long. Publishing in a paper journal means that the paper will live forever in libraries. The British Medical Journal combines the two. It prints short and readable versions with longer versions available online. Is this okay with authors? The journal asks a random sample of 104 in its recent authors, several questions. One question was, should the journal continue using this system? In the sample, 72 said yes. Do the data give good evidence that more than 2/3 of the authors support continuing this system? Carry out an appropriate test to help answer this question. Okay, when you're doing the state part, my best hint for you is go right to the question, and that's going to help you. Will it always work? No, it's just a hint. Oftentimes people want to use this 72 and this 104. That's not going to come until for a couple days. That's our statistic. That is our p hat. That's what we found. That's our evidence. Okay. Right now, we're not dealing with any evidence. We just are at that state part. So the first thing that we need in the state part is we need that p, that population parameter. What are we trying to figure out? Right now, we think it's 2/3. Okay. Or we're trying to figure, I'm sorry, forgive me, let me rewind. We're trying to find evidence that's more than 2/3 support the system. So P, like I said, is always a statement, the true proportion of what? What is the story about? Go to the question. The story is about authors who support continuing this system. So the true proportion of authors who support continuing, I can type, I promise, this system. Now we need a null hypothesis and an alternative hypothesis. We will always have P's with it, so I'm going to put a P right there and a P right here. Now, we don't necessarily know the current truth right now. It doesn't tell us that 67% right now do believe that. But it does ask us what is the evidence that we're looking for right here. And if you look at our notes from the previous page, our HA is always about what we're trying to find evidence for. So if it doesn't tell you a claim and you can't start there, go to the HA. We want to know if that true proportion, give me a second, is greater than 2/3. So I'm going to put greater than 0.67 because that's the percentage they give us. We always want to keep it as a decimal, okay? So what does that mean? We're going to take that decimal, move a 2 to the left, or we're going to divide by 100. Now, if we know one of these, we just about know the other. We know that HO always is an equal statement. If we don't know that, I'm telling you that now. Oops, sorry, my cursor's in the way. Okay. And these numbers here always have to match. So I'm going to put 0.0 or 0.67 as well. And that's all we need for today. The parameter, the null hypothesis, the alternative hypothesis. Okay. Let's do another one together. At this point, I want to encourage you, maybe you could try this on your own, pause and then check your work, just as a quick check for understanding. But if you still don't get it, here's your second chance. Write down any questions that you might have and make sure you share those with your teacher. Okay, number 2, according to the Humane Society, 33% of households in the United States own at least one cat. You are interested in determining whether the proportion of households of the students at your school that own at least one cat is different from the national proportion. Okay, we don't have any evidence here. They don't give us a statistic or a sample, but that doesn't matter. All we care about today, 3 things. Do you know them? The parameter, P, the null hypothesis, and the alternative hypothesis. So P is always the true proportion. What is this story about? Go again to the question. You're interested in determining whether the proportion of households of the students at your own school own at least one cat. So we get that context. We get that context from the story there. Use that to help you. So we have an HO then. We have an HA. It will always have a P with it. And now we're going to go to, hey, now they give us a current truth. Right now the current truth is 33% of households own that at least one cat. So P is equal to 0.33. What are we trying to figure out? If it's different from the national proportion. So what does different look like? That's going to be a not equals. So I'm going to get a copy of that right now from my math type right there. Let's see if that will work for me. It didn't, so I'm going to have to take a picture. Give me a second. I'm going to send it to the same page. Right there. Perfect. We're interested to see if it's different. Okay, so one common question is how do I know which way that HA should go? Should it be a not equal to? Should it be a less than? Should it be a greater than? You really want to look for words that help you decide what that HA should be. So more than 2/3. That told us that we're looking for a greater than here for that HA. Different, that doesn't mean more than, that doesn't mean less than, just different, which is a not equal, okay? All right. And then a less than. So let's do this one together as well. Again, I encourage you to pause it, try it on your own, see if you can get it right. 11% of the products produced by an industrial process over the past several months have failed to conform to specifications. The company modifies the process in an attempt to reduce the rate of nonconformities. In a random sample of 300 items from a trial run, the modified process produces 16 non-conforming items. Do these results provide convincing evidence that the modification is effective? Support your conclusion with a test of significance. Now, you don't know how to do all that tests. You are just wanting to do this state. The three things, again, do you know them? P is the parameter, the null hypothesis, the alternative hypothesis. Okay, let's do it. P is always the true proportion. What is this true proportion about? Well, what's the story about? The true proportion of, we're looking of nonconformities, okay? So the true proportion of non-conforming products. You have a null, you have an alternative. It's always P equals, and then it's a P and you have to decide, okay? Now, do they give us a claim? We see this 16 out of 300, but we're not gonna use that. Why are we not gonna use that? That's our evidence right now. That's what we use later. That's our statistic. 16 out of 300 is describing the sample. We want the parameter. The parameter is describing the entire population. 11% right now is that parameter, okay? That's describing the true proportion right now of non-conforming products as claimed by this industrial process. So I'm gonna put with that P, 0.11. Now these numbers always have to match, 0.11 again, and we just have to decide what goes there. Is it a less than, a greater than, or a not equal to? And now what they tell us is there evidence that this modification is effective? Which means, how would we want that percentage to go? Do we want the 11% to be greater than, less than, or not equal to? Well, it's not good to have non-conforming products. So we want that to go down, right? So we're gonna put a less than symbol right there. All right, I hope you feel comfortable with today's notes. Please look for a video as well. As you're doing the worksheet, there's a couple that pop up that don't necessarily give you that parameter and you have to decide what it is. So I am gonna make helpful hints for your homework video. So check that out if you're struggling on the homework at all. Have a great day, you guys.